Hi everyone, I'm going to show you guys how to do this question. So it's a center of mass question and they've given us an inverted frustum and a hemisphere. So they're asking us to find the center of mass from the base of the solid. As you can see in part A, so they've given the density of the hemisphere is P. They say given that the density P of the hemisphere is 3 times the density of the frustum. So then density of frustum equals P over 3. Because the density of the hemisphere is 3 times the density of the frustum. So if you multiply P over 3 by 3, you get P, right? So I hope you all understood that. So now to find the center of mass for this shape, we need to find the volumes of both the shapes separated, right? So let's find the volume of the hemisphere. I'll call it VH. So that equals to 2 over 3 pi r cube, right? Which is going to be 2 over 3 into pi into the radius of the hemisphere, which is 10 cube. This giving you 2000 pi over 3. But since they've given us the density, we'll have to consider the mass. So the density of the hemisphere, I'll write it as dH equals to mH over VH. So density equals mass over volume. So I wrote H just to resemble the hemisphere, right? So we get mH equals to 2000 over 3 pi into P. So I'll just write it as 2000 pi over 3 E. So that's your hemisphere. Now let's focus on the cone. So this is the shape we have. Let me just draw a small diagram to explain it to you guys. So this is your hemisphere and this is the frustum. So can you see the frustum is actually a cone, was initially a cone, and a smaller part of the cone was removed to create the frustum, right? So we'll have to find the volume of the larger cone and subtract it with the smaller cone to get the volume of the frustum, right? So we know this height is 30 and this is 10. The radius of the hemisphere is 10. The radius of the base is 5. We could call this x, this height, the height of the smaller cone, as x. So we can write the larger cone's height is going to be 30 plus x, right? Over the radius of the large cone, which is 10, equals to the height of the smaller cone, which is x, over the radius of the smaller cone, which is 5. So 150 plus 5x equals to 10x. So we get 150 equals 5x, x equals 30, right? So now let's find the volume of the large cone. I'll write LC for large cone. So it's 1 over 3 pi r squared h, right? So 1 over 3 into pi into the radius of the large cone, which is 10 squared into 60. This giving you 2000 pi, right? So that's the volume of the larger cone. And we could also find the mass of the large cone. So mass of larger cone would be the density of... So in this case, so the frustum has the density of P over 3. So it's going to be the same for the cone, right? Because it's the same material. It's just that a smaller cone was removed from a larger cone to create a frustum. So it's the same material, so same density, right? So the mass of the larger cone is going to be P over 3 into 2000 pi. Okay, so that giving you could just write it as 2000 over 3 pi d. Okay, and the mass of the smaller cone, alright, SC equals to P over 3 into its volume, which is 1 over 3 into pi into the radius of the smaller cone, which is 5 squared, into the height, which is 30, giving you the answer 250 over 3 pi p. Okay, so we found the masses. So what we have to do now is to find the center of mass. So I'm going to take the center of mass. So they ask us to find the center of mass from this axis, right? The dotted line I just drew now. So I'm going to take the center of mass from this line. You see the dark line that I'm highlighting now? I'm going to take it from that point, and then later I'm going to subtract it with another length to get it from the dotted line. I'll show it to you guys, right? So it's going to be the mass of the hemisphere, which is mh, into its center of mass, which is 3/8 its radius, plus, so the center of mass of the hemisphere is over here. So we need to add the total distance. So it's 3/8. This is going to be 3/8r. And you need to add it with 30 and x, right? So giving us 30 plus 30, which is 60. So it's 3r/8 plus 60. Plus the larger cone, which is going to be MLC into, so the center of mass for the larger cone would be somewhere here, and it would be 3/4 its total height. So that into 3/4 h, which is going to be 60, right? Subtracted by the smaller cone, because it's removed, right? The smaller cone is removed, so its center of mass would be somewhere here. The same thing again, 3/4 h. So MSC into 3/4 into 30 equals to COM dash, the total mass of the whole solid, MH plus MLC minus MSC. So this is the formula you have to use. Now what we have to do is just sub in the values. So MH we found was 2000 over 3 pi, 2000 over 3 pi p into, so 3/8 into 10, which is r, plus 60, giving us 63.75, plus MLC, which is 2000 over 3 pi p into 45, minus MSC, which is 250 over 3 pi p into 22.5, equals to COM dash, which is going to be COM dash into the total mass of the solid, which is 2000 over 3 pi p, plus 2000 over 3 pi p minus 250 over 3. Let me just write it below, 250 over 3 pi p. So you can see pi p cancels off, right? It's common. So you just end up with a bunch of numbers now. Okay, so I get the center of mass as, so COM dash. Now remember, this is from the dark line I just labeled. It's not going to be your final answer, alright? So we got, so 70,625 divided by the total mass, which is going to be 1,250, which will give you a center of mass of 56.5 centimeters. So 56.5 centimeters is from this dark line. So how do you find the center of mass from the dotted line? So if it's 56.5, so 56.5 would be somewhere, let me just erase all this. So if this whole length is 60, right? 56.5 would be somewhere here, let's say 56. 0.5 is here. So how would you find the distance from this point? So you know this distance is 30, right? This distance is 30. So all you have to do is to subtract 56.5 with 30. So your final COM, center of mass, from base is going to be 56.5 minus 30, giving you 26.5 centimeters, which is 0.265 meters. If they ask the answer in meters, you could write it either way, it doesn't matter. So this is the answer for part A. So for part B, let me just draw the diagram. So for part B, this was the answer for part A. Your diagram, if you go to your question, you can see so let me draw a rough diagram. 45 degrees. This is your solid and this is the force at point A. We call it FA. And mass mg. So what they say in part B is, given that the total mass of the compound solid is m kilograms, work out the minimum horizontal force in terms of m that must be applied at A to stop the solid from toppling over. The plane is sufficiently rough to prevent slipping. Alright. So to prevent toppling, so if this object topples, it topples from this point, right? I'll call it C. It's gonna topple from point C, right? So if you picture this solid, if you picture it toppling, let me just draw this again properly. Just picture, like, imagine as if this object is toppling. So when it topples from point C, this part lifts off, right? That part lifts off. So the only contact point for the solid is going to be point C. So we don't have to worry about the reaction force or friction. Alright? We'll have a reaction force on point C and we'll have a friction on point C because that's the only point of contact when it's toppling. But we don't have to consider that because we are taking the forces about point C. So the friction and reaction force lies on the pivot, right? So we don't have to consider them for moments. It's only the other forces that are away from the pivot that we have to consider. So we're going to take moment about C. Okay. This distance was 0.265, which we just found. That's the center of mass. It's meters, by the way. So it's 26.5 centimeters. All right. So we have FA, right? To find the moment, we'll have to find the perpendicular distance for FA. So this would be your perpendicular distance, right? No, without taking that way, let's try another way. That's a bit complicated. Oh, wait a minute. If you look carefully, I'm gonna draw a dotted line like this, okay? And if I draw another dotted line over here, so this angle is 45. This angle is also 45. So to find this distance, which we can call x, we'll first need to find this distance, right? The blue dotted line. We first need to find this distance. So to find that, we know the height of the compound solid is 30 plus 10, so 40. And this distance is 5, right? So to find the blue dotted line, all we have to do is just find the Pythagoras theorem of 40 squared plus 5 squared. So this would give you root 40 squared plus 5 squared, giving you 5 root 65, which is gonna be the blue line. I'll just write blue line like this, okay? Okay, and we'll also have to find the angle, this tiny angle. So how do you find that? We can call it alpha. That tiny angle alpha is gonna be, so tan alpha equals to 5 over 40, right? So this would give you tan inverse 5 over 40, which is in degrees, so it's 7.125 degrees, alright? So to find this angle, beta, we could write beta equals 45 minus 7.125 degrees, right? So 45 minus that gives you 37.87498 beta. And to find x, so x is gonna be, so the blue line was 5 root 65, so it's gonna be cos beta, 5 root 65 cos beta. When you resolve it, you will get this distance x. So you'll have 5 root 65 cos beta, it gives me distance x, which is 31.8198 centimeters, right? Okay, so now we could take moments about C like this. So F A into 31.8198, okay, that's gonna be your anticlockwise moment, equals to, now we have to consider the mass, mg. And if you look carefully for mg, we could resolve it this way. Let me erase that again. Oh, I'm sorry. Okay, so we could resolve it this way, and we can resolve it this way, right? So we'll have mg sine 45 into its central mass, which is 26.5, minus mg cos 45. So cos 45 is gonna be anti-clockwise to the pivot, right? Because it's this line. This is cos, this is sine. So mg cos 45 into the perpendicular distance, 5. Using this, you could find FA. So FA would be, let's see what we get. So I get FA as 0.47777. It goes on. So you could write 0.478 mg. This is your answer. So if you guys have any doubts with this question, please drop a comment. So you guys can understand of what I've done here, right? Is the diagram a bit hard to understand? So just tell me if you guys have any doubts. I'll help you guys out. So this is everything for this question. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.